Hello everyone, this is Mr. Appel, and today we're going to do some rational equations. I'm going to apologize in advance if you hear any strange noises in the background. I'm at my daughter Sophie's rehearsal tonight for her play, and I couldn't find a quieter spot, so hopefully this will work for you. Here we go. So we're solving rational equations, so that's equations involving rational expressions, like the one you see here. So if you haven't already done so, you should pause and copy that down. And now what we're going to do is use a method that I like to use for problems like this, where we clear out the fractions. We're going to multiply the entire equation by essentially what would be the common denominator if we were trying to find one. So I look at the factors of all the denominators and use them to determine the least common multiple. So the least common multiple of x minus 3, x plus 2, and 1. And so I'm going to multiply the entire equation by those factors. So by x minus 3 and by x plus 2, and of course the 1 doesn't really matter. And the reason I do that is because now what happens is I multiply that by each term. So when I multiply that by the first term, the x minus 3's cancel out. The x minus 3's cancel out when I multiply that. So I end up with, on the top, 2 times just the x plus 2, or 2x plus 4. Now when I multiply those two by this term, the 3 over x plus 2, the x plus 2's cancel out. Alright, that's probably a little distracting. Okay, we'll continue. The x plus 2's cancel out, and we're left with the 3 times the x minus 3. Which is 3x minus 9. And then over here, the denominator is 1, so nothing cancels. So it's just going to be 4 times this, x minus 3 times x plus 2, which if I multiply that out is x squared minus x minus 6. So now that's 4x squared minus 4x minus 24 equals 5x minus 5. Now, it's still a little messy, but now we have a quadratic that we can solve. So I'm going to go ahead and set that equal to 0. So we have 4x squared. I subtracted the 5x, so that's a minus 9x. I'm going to add the 5, so that's minus 19. And now we have a quadratic that we can solve. Still messy. We might try to solve that by factoring. Turns out this isn't factorable. So I'm going to go ahead and use the quadratic formula on this. So the quadratic formula, negative b, there's my b, so that's 9, plus or minus square root of b squared minus 4 times a times c, all over 2 times a. This should be familiar to you. Quadratic formula in action. If I evaluate all that stuff under the radical, it's 385. I did that ahead of time to save some trouble. All over 8. And now it turns out that the square root of 385 is can't be simplified. It's not a perfect square. And so this is actually my answer. Can't simplify that any further. What you do have to remember here, though, is to look for problem answers, to look for solutions that would make the denominators 0. But clearly, if I plug this in, it's not going to cause a problem. We don't have to worry about what we call extraneous roots, right? Because if I plug that in for x, it's not 3, which would make this one blow up, and it's not negative 2, so we're good to go. Okay, let's look at another example now. This example, we've got an x minus 1 down here, an x minus 3 down here, and we've got this x squared minus 4x plus 3 over here. So again, I want to use that same strategy of multiplying by the factors. So if I factor this denominator, I see that it's just x minus 3 times x minus 1. And so what I'm going to do is multiply the entire equation by those two factors, by x minus 3 and by x minus 1. So This isn't too awkward. I'm making a video for my students right now and I can't pause it. Yeah. Go ahead, say hi to my kids. Hi. We're doing pre-calc. So if we multiply this first term in the expression, the x minus 1's cancel. So we just have the 2x times the x minus 3, which is 2x squared minus 6x. And if we multiply that by the middle, by this term here, the x minus 3's cancel, and we're just left with 1 times the x minus 1, which is just x minus 1. And over here, everything cancels on the denominator, so that cancels, and that cancels, so we're just left with 2. So let's subtract the 2, bring that over to the other side. We've got 2x squared minus 6x. Oops, not minus 6x. Let's try that again. We have 2x squared minus 5x minus 3 equals 0. And this one is factorable. This one is factorable, so that's 2x and x. And if we do a minus 3 and a plus 1, we can solve this one by factoring. So this is going to give us a 0, or a root of negative 1/2. And this will give us a root of, or a 0 of x equals 3. But we have a problem. X equals 3 is an extraneous solution, because if you plug 3 in, it doesn't make this equation true. Remember, when you solve an equation, the goal is to find the values of x that you can plug in that will make that true. But if you plug 3 in, this blows up and it doesn't work. So we actually have to throw that out, and our only solution then is x equals negative 1/2. And that's all for today. Thanks.